All right, moving on to the motion part. A tennis ball is released from rest and falls vertically through a small distance in the air. What is the change in speed of the tennis ball and in the acceleration of the ball as it falls? So the acceleration is simply, and we're going to actually neglect air resistance. So the acceleration, no, let's see. We are accounting for air resistance, it says, in the air. So the acceleration is going to decrease as air resistance kicks in and reduces the effect of gravity by applying an upward force until the acceleration decreases to 0. So we will decrease, so either A or D is correct. Now the speed of the ball will in fact be gaining speed as it moves. So choice A is in fact the correct choice for this problem. Problem number 2. This is the velocity graph, and we want to know what the displacement looks like as a function of time. So let's be clear. Here we're going to have a line with a positive slope, and then here we're going to see the lines, and then we're going to see the plot get start off steep and level off to flat as the velocity decreases to 0. So we're talking about choice C here. All right. And then for number 3, we have velocity versus time. So what can we say about this truck? So let's look at choice B. It says the truck is always moving right here via 0. So that's not true. Is the truck always moving in one direction? Well, it's positive going forward here, negative going backwards here, so that's false. Is the truck always accelerating? I'm not completely sure. It seems to me that we never really quite get a flat part. So yeah, I need a really definitively flat graph on a velocity to have no acceleration. So clearly the truck is accelerating. Now how do we know the displacement isn't 0? We compare the areas. So compare the area here, I'll call that region 1, to region 2, and we can clearly see that the area of region 1 is greater than the area in region 2, and that tells us that the displacement is in fact greater than 0. So that rules out choice D, because remember, displacement is the area under the velocity graph. And that's how we work. All right. So problem number 4, an object is dropped from rest above the Earth's surface. Air resistance does act. What's the variation of acceleration with time? So we're going to actually not have constant acceleration. Oh my goodness, this suggests that we have a constant acceleration that gets steeper and more negative. No, no, no. And here this suggests that we have an acceleration that starts off as not existing and then suddenly increasing and leveling off to a constant. That is not what happens to the acceleration. That might be what happens to the velocity, but not the acceleration. What we do have is we have a positive acceleration of 10 meters per second squared that becomes 0 as time goes by. So choice D is in fact the correct choice. Problem 5, a body moves in a straight line. Graph shows displacement versus time. Which shows motion with negative acceleration? Let's be clear. Not this, not this. Those are steady. So there's a choice between C and D. Now, negative acceleration means that I have a positive slope that becomes flatter as time goes on. So that would be choice D. And then finally for choice E, we have acceleration versus time, and we want to know the speed of the particle at 6. So to do that, we'll get the area at 6 seconds. So that can actually be right here. V is going to be the area of this acceleration graph, which is going to be 1/2 times the base, which is 6, times the height, which is 3, and that's going to give me 9 meters per second. So those are our kinematics problems. I will post these videos and put the solutions on Haiku.